Okay, hey folks, for this very last video for chapter 15, we're going to talk about salts that have acid or base properties. Okay, so I've got a little key here to help us remember. All right, and so we'll say that salts that have anions of a strong acid, right? Because remember, if we're talking about the strong acid, HA dissociates into H plus and A minus. We're not talking about the H plus. What we're really interested in here is the A minus, the anion. So salts that have anions of strong acids plus cations of strong bases have no effect on pH. Okay, and so another example of this now is, let's say sodium hydroxide. We know when sodium hydroxide dissolves into Na plus and OH minus, now we're saying here the Na plus has no effect on pH. Okay, so the anion of a strong acid, the cation of a strong base have no effect on pH. And when they dissolve, they are all neutral at pH equals 7. Okay. So, for example, HCl, right? We know that's a strong acid. When that dissolves into H plus and Cl minus, the chloride has no effect on pH. Okay. When, let's write, when, on the other hand, HF dissolves in water, we know it's a weak acid, so it's in equilibrium with H plus and the F minus. This F minus will have an effect on pH. Okay. Alrighty. So now, how do we think of an example? Okay. So here's an example salt that produces a basic solution. I gave you another one, which was HF, but here's also another one, sodium acetate, because we recognize acetate is the anion of acetic acid, right? So when it dissociates, it makes the acetate ion, and now this is how it's able to make a basic solution, because now the acetate will grab a proton from water and make hydroxide, okay? So even though that seems backwards because that's the anion of a weak acid, it's the opposite case. Anion of a weak acid makes a basic solution. Okay, so an example salt that produces an acidic solution, ammonium chloride. Okay, so we recognize that the ammonium is the cation of a weak base. And that's not immediately obvious, cation of a weak base. So that's probably, like I said, not too obvious, but we recognize that it is a cation, and it came from the ammonia base compound, weak base. Okay. So now, when ammonium chloride dissolves in water, it makes ammonium, right? And we know that the chloride has no effect on the pH. Okay. But now this ammonium can donate a proton to H2O. And that will make NH3, but also H3O plus. So it will make an acidic solution. Okay. So now, what about the case when we have mixed cation anion? Okay. So this is a really important relationship that I want you to know. Ka times Kb equals Kw. We remember that Kw is 1.0 times 10 to the minus 14, okay? So this relationship holds for any weak acid and its conjugate base, okay? So as one example, we looked at carbonic acid, right? H2CO3. And we remember that carbonic acid dissociates into its first proton H plus and HC3O minus. Okay, so we have a Ka for carbonic acid that came from the previous slide. Let's grab that really quick. There it is, 4.3 times 10 minus 7. Okay, So now if the Ka for carbonic acid is 4.3 times 10 minus 7, we can calculate the Kb of bicarbonate from this relationship right here. Okay, and so if I rearrange now, so that's going to be Kb equals 1.0 times 10 minus 14, all divided by the Ka, 4.3 times 10 minus, not 17, minus 7. Let's write that again. Okay, so we'll calculate that really quick. So 1e to the 14 divided by 4.3 e to the minus 7, okay, equals, let's see, that I know is not right. So 1e to the 14 minus, I might have entered my calculator wrong. So then divided by 4.3 e minus 7 equals, okay, that I know is the right answer. So that equals now 2.3 times 10 to the minus 8. Okay, so why is this relationship important? Well, when we have examples where our cation and anion both come from weak bases and weak acids, we have to use this relationship, okay? But just as a reminder, let's back up here, right? If our source of the cation is a strong base and the source of the anion is a strong acid, we know that it's a pH of 7, so no effect, okay? But now we remember that if the source of the cation is from a weak base and the anion is a strong acid, that made an acidic solution. Remember, ammonium chloride was our example acidic solution, okay? On the other hand, if the cation is from a strong base, but the anion is from a weak acid, and so that makes then a basic solution, pH is 7 greater than 0. And I showed you sodium acetate on the previous example, but sodium fluoride works because the fluoride is the anion of HF, the weak acid. But now back to where I started. If both the cation and anion come from weak base and weak acid, here's now where we have to use this relationship, okay? Where we have to decide, right? So if the Ka is greater than the Kb, then it's going to be acidic. If the Kb is greater than the Ka, then it's going to be basic. And if the Ka equals the Kb, then it's going to be neutral. There's only one of these examples where the Ka equals the Kb, and that's actually, oddly enough, for ammonium acetate, is this example here where the Ka of ammonium, okay, because remember, we have to think of this now as which one is acting as the acid, and we remember the ammonium acts as an acid, okay, and the acetate acts as a base. This is the peculiar example where the Ka equals the Kb. So as it turns out, ammonium acetate does make a a neutral solution. Okay. But now, what about the ammonium carbonate? Okay. Well, we would have to compare. We'd have to know. We would want the Ka. So let's write that down. Ammonium bicarbonate. Okay. So we would need the Ka for ammonium. And let's see, do I have that written down? Let's see. Of course, I don't have that written down. But we calculated the Kb, right? There it is for bicarbonate. So we know that Kb is 2.3 times 10 to the minus 8. So if the Ka is greater than this Kb, then it's acidic. If the Ka is if the Ka is less than Kb, then it makes a basic solution when dissolved. And let's see here. I'm looking through my notes to see where I wrote it. Oh, I have it right here. I just can't see. So the Ka for ammonium is 5.6 times 10 to the minus 10. So this is a scenario when the Kb is greater than the Ka. So that means ammonium bicarbonate makes a basic solution. Okay. That's it for chapter 15, folks. Hasta luego.